Message passing is where threads communicate by sending each other messages containing data. For this to be accomplished, Rust uses channels, which is a concept that the standard library provides for us. The channel has two ends, a transmitter and a receiver. The transmitter sends data and the receiver takes in that data. A channel is considered closed when either the transmitter or the receiver end is dropped. So let's take a look at how these channels work by implementing one where the transmitter will send a string to the receiver who will then print out that string. So the first thing we need to do is import in the crate that provides channels for us, and that is standard sync MPSC. And now to create a channel, we will say let transmitter receiver, so a tuple, equal MPSC channel. Now we can spawn a thread that's going to say, and we want to pass in a value, so we'll say let val equals string from transmitting. And now we can say transmitter.send, we want to send the string, and then it returns a result, so we need to unwrap it. For our receiver to receive, we just say let message equals, let me put this semicolon before I forget, receiver dot receive, and then this also returns a result, so we need to unwrap it. And now we can print out the message that we received. And if we run this, we see that we see transmitting. So MPSC stands for multi-producer single consumer, which is essentially a description of how channels work. So now let's look at how we can create multi-producers. But first, let's actually talk about ownership rules and message sending, because they do help us write safe concurrent code. So when we use this send function, it takes ownership of the value being passed in as a parameter, and then when receiver receives it, it takes ownership of that value. And then obviously that result is returned back here to our message. So there's nothing new with this ownership rule, but it's important to know that that is how ownership is working inside these channels. And Rust is doing this so that when we send a value, we don't try to reference or use that value later on. So an example of this is if we tried to print out our val down here. And this is going to be a compile time check for us, like all the other ownership rules. That way we cannot reference a value that no longer is valid. So it is a compile time check, which is great for us. But now let's take a look at how we can create multiple producers. So I want to make sure I don't have that error anymore. And creating multiple producers is actually pretty easy. So we can say let tx, and this is a shortened way of saying transmitter, and now we will say transmitter.clone. And now we have another producer. So I'm going to comment all of this out. That way it's a clean slate. And now we want to transmit a couple of messages. So we'll say thread spawn, and then we'll have let vec equals, and now we want a new vector to contain some strings. Transmitting, and now I'm going to copy and paste this to kind of speed it along from original. Alright, and then to transmit it, now that we have a vector, we'll say for each value invec transmitter.send the value, and now unwrap it, because remember it returns a result. And then we want to close it out. Now let's format it to make it look pretty. And now we want to do this again, but with the second producer we created. So we'll modify that to btx, and then we will say the clone is, if I can, there we go, transmitting. Alright, so now what do we have? We have two threads spawned. Our first producer is going to transmit from original, and our second one is clone is transmitting. So now we want to set our receiver up to be able to receive all of these messages. So we'll say for rec, short for received, and receiver, we want to print out all these values that we received. And now if we run this, we see transmitting from original, and now we see clone is transmitting. So that worked exactly as we intended. We had multiple producers and one single consumer. But you might be wondering is, what happens if our receiver can't keep up with the amount of messages being put in by our producers? Well, the way it works is the messages are being sent and are getting put into a queue until the receiver is ready to handle it. So the queue could become overpopulated. And when the queue is constantly being added onto and the receiver cannot keep up with it very well, we actually start to waste resources, because we are using resources sending values when we actually need to allow the resources to be more allocated to processing the data being sent in. So to alleviate this, Rust does provide us with a solution called SyncChannel. And what SyncChannel is instead of just being channel, we'll say SyncChannel, and then in here we can put a value. So I'll put 1,000. And a SyncChannel is going to work the same as a regular channel, but we are specifying how many values our queue can hold. And then the send method becomes a blocking operation once the queue is filled up. So once our queue reaches 1,000 values, the next time we hit send, it's actually going to be a blocking method until our receiver starts to catch up on the amount of values that are in our queue. So this in turn allows our receiver to be able to use resources more efficiently. Remember, blocking does not necessarily mean we lose performance. We could possibly see resource improvement without losing any throughput in our channel. So this is something that I just wanted to make you aware of.